Hello and welcome to Lesson 4.7 Introduction to Coordinate Proof. Today's objective will be to position figures in the coordinate plane for use in coordinate proofs. And we will prove geometric concepts by using coordinate proofs. Our emphasis really will be on positioning the figures in the coordinate plane and learning how to do that. For the warm-up, there are some formulas that you will need. For finding the midpoint, you're going to want to use the midpoint formula. For finding the length of one leg of a right triangle given the hypotenuse in the other leg, we're going to want to use the Pythagorean theorem. And on number 3, finding the distance, we want to use the distance formula. So I've given you all these formulas, and it is very important that you write these in your notes because you will also need to use them on the assignment in class. So make sure you write these down. A squared plus b squared equals c squared for the Pythagorean theorem, the midpoint formula here, and distance formula here. Make sure you write these down. You're going to need to use them. So take a few moments, pause the video if you need some extra time, but go ahead and try and work out, ignore that, sorry. Go ahead and try and take care of these warm-up problems. Alright, here's what we should get for our answers for each of these. When we plug in our values, we get y as the x-coordinate and x plus z as the y-coordinate. For number 2, whenever we plug in our values here, we get that the other leg, which I've called b, is 5. And number 3, the distance between these 2 points, as long as b is greater than a, is b minus a when you plug it all in. Because right here, for the x's, we get 0, so we don't have to worry about that. The square root of the quantity b minus a squared, the square root cancels out with the squared part of this, so we get just b minus a. Once again, make sure you copy these formulas down. The midpoint formula, Pythagorean theorem, and the distance formula. We've got one other formula that's going to be really useful in this lesson, and we will talk about that in just a moment. But I'll go ahead and tell you what that formula is. That is the slope formula. The slope of a line is the difference of the y-coordinates over the difference of the x-coordinates, rise over run. So we will use slope formula as well. All right, let's take a look at our first example. Before we do that, here's what coordinate proof is. It's a style of proof that uses coordinate geometry and algebra. The first step of a coordinate proof is always to position the figure in the coordinate plane. You can use any positioning, but some strategies make the steps of the proof a little bit easier. We could keep our figure all in the first quadrant using the origin as a vertex, because the coordinates of the vertex then would be 0, 0. Those are easy to find. We could center the figure around the origin. Sometimes that would also be helpful. We could center one side of the figure at the origin, or we could put the sides of our figure along the axes if there's a right angle there, and again putting one vertex at the origin. This will be very helpful, especially with triangles. This last one is how I will position most triangles in these examples. So let's take a look at example 1. We need to position each of these figures according to what we're given here. We want to position a square with side lengths of 6 units. That can be any kind of square we choose. As long as the sides are 6 units, we can position it anywhere we want. So we're going to find a square and position it so that it is 6 by 6. Well, our scale counts out 5 in each direction, so I really wouldn't be able to position a vertex at the origin, so I'm going to make my figure centered at the origin so that I have enough room. So I'm going to make my square 6 by 6, 3 on either side of the x-axis, 3 on either side of the y-axis, makes it 6 by 6. Well, then the next thing we need to do is talk about the coordinates. All right, we would have coordinates -3, 3, +3, 3, +3, -3, and lastly right here, -3, -3. So there's the coordinates. But once again, I could position the square anywhere in this graph that I'm given, and the coordinates would be different, but it would still fit that criteria. But right now, this is the best fitting square I can think of. Number 2, we want to position a right triangle with leg lengths of 3 units and 4 units. Well, if it's a right triangle, the axes form that right angle, and I'm going to put one vertex at the origin, so I'm going to make that my right angle. So this is how I want you to position your right triangle. We are going to count 3 units for one leg, so you can pick horizontal or vertical. I'm going to pick vertical for that 3 unit leg length, and 4 units for the other leg. So I'm going to go over this way 4. And then I have to finish by constructing the hypotenuse, and there is our triangle that is 3 by 4. We need to fill in those coordinates though. One coordinate's the origin, 0, 0. Then this coordinate right there would be 0 for the x-coordinate, and we've gone up 3 units, so 3 is our y-coordinate. The other vertex coordinates would be 4 units to the right, so our x-coordinate is 4, and our y-coordinate is still 0. That's why it's a good idea to position our figure using the axes and the origin, because we get zeros for a lot of our coordinates, makes it easier to work with. In example 3, we want to position a triangle with a base of 8 units and a height of 2. It doesn't say what kind of triangle you have to use, so we can make any triangle, but I don't have a full 8 units to count vertically from x, so I'm not going to make that my base. I'm going to make my base go left and right, and I'm going to make my height 2, so I'm going to center the base at the origin along the x-axis. So I'm going to make one side of my triangle go from -4 to +4, which is a base of 8, 4 on the left, 4 on the right, and then the height just measures up to 2. So I'm going to make the other sides meet up here at 2 on the y-axis. We have a base of 8 and a height of 2. Why don't you take a moment or two to tell me what those coordinates are? Okay, we do have these coordinates. This is -4, 0, this is 0, 2, and this is 4, 0. Alright, for number 4, why don't you read through this and see if you can find a way to position a rectangle with a length of 6 units and a width of 3 units on this figure. Notice I've given you more space above the x-axis, so we probably want to center one side along the x-axis, or you're more than welcome to put a vertex at the origin because you have enough space to do that. But go ahead and position that there, and then we'll take a look at what our coordinates should be. Okay, here is the rectangle I chose, where I have 3 for a width, 6 for a height, or in this case a length. But this rectangle could be positioned several different ways. This also works. Positioning it like this. I could position it in the negatives, but that's probably not going to help me a whole lot. So most of you probably did something like this. Alright, if we choose to do this, then our coordinates are going to be the origin, 0, 0. This coordinate, or this vertex, has coordinates of 6 for the y and 0 for the x, so we say 0, 6. This other vertex along the x-axis has an x-coordinate of 3, a y-coordinate of 0, and then because I've gone 3 this way from my x-coordinate here and 6 this way from my y-coordinate here, the last vertex up here at the top is 3, 6. Now, we can also place figures in the coordinate plane without knowing specific measurements. We could use variables to represent those, and we can assign variables as the coordinates, like this. So let's say we had a right triangle with leg lengths C and D. Well, if I position that in this way, one vertex, the right angle, is at the origin, has the coordinates 0, 0. So the side length D, we would count up D units to get here. You could have chosen C or D, but we've chosen to count vertically for the D length. So the x-coordinate is still 0, the y-coordinate is D. And that makes our x-coordinate the side length C here, and our y value is 0. So this is kind of a way to position a triangle in the coordinate plane with these measurements. Again, you don't have to know specific numbers. I've put these on grids, but you aren't going to necessarily worry about counting a certain number of spaces. We're not going to put any numbers on this other than 0. So the first thing I wanted us to do is position a right triangle with leg lengths S and T. So if it's a right triangle, again, it's a good idea to position our legs with that right angle vertex at 0, 0. So I'm just going to make these any length that I want. They don't have to be different lengths. They don't have to be the same. And then I'm going to draw the hypotenuse. And then I'm going to try and label what the vertices are. We know this one is at 0, 0. We picked the origin, so I could clearly label that. If you choose to make S your vertical length, that means the coordinates here, the x-coordinate is still 0, but the y-coordinate is S. And then this would have to be t for the x-coordinate, and then y-coordinate is 0. So why don't you take a moment or two to construct a square with side lengths k. Okay, your square should look something like this, and we're going to make, again, one vertex at the origin using these side lengths so I can use zeros as much as possible. Alright, the origin coordinates are 0, 0, and then k is the length of each side. So the coordinates here, 0 is the x-coordinate because it's on the y-axis, and our y value that we're picking is the length k, so y is k. Over here, the y value is what is 0, because we're on the x-axis, and our x-coordinate is k. So the coordinates at this point, out here in the first quadrant, we have k for our x-coordinate and k for our y-coordinate. So why don't you take a moment to try and position rectangles with leg lengths L and W, and a triangle with base B and height H. Remember, we can still use a right triangle as long as one leg is called the base and the height is called the other leg. Okay, your figures might look a little bit like this. Again, they may not be exact, but your coordinates can still be the exact same thing that I have. A rectangle with leg lengths L, if I position it, and this is the part of ours that should all be the same, one vertex should be at the origin, 0, 0. The other vertex here, if I call that my width, the x-coordinate is 0, the y-coordinate is W. This coordinate over here would be my length, so the x-coordinate would be L, y-coordinate is 0. That makes our coordinates L for x, W for y. In this one, a triangle with base B and height H, the base is what I'm calling this horizontal leg. So our coordinates would be 0, 0 for the right angle, and B, 0 for this vertex. This vertex at the top would be 0 for the x-coordinate, and then this is what we're calling our height, so y-coordinate would be H. Alright, there's one last example we want to go through. We want to describe how we could use formulas for midpoint and slope to actually do a coordinate proof. A coordinate proof requires you to position a figure in the coordinate plane and then use formulas to arrive at conclusions. And you're going to figure out a little bit more how to do that when you do the assignment. There's some problems that walk you through how to do a coordinate proof. But in this problem, we're just going to describe how we would use these formulas of midpoint and slope to do a proof. So we're just going to write a description here. Here's what you're trying to prove. You want to prove that two lines are parallel. In the coordinate plane, that means you have to show that they have the same slope. So here's what you're going to do. In triangle HJK, R is the midpoint of one side, S is the midpoint of the other. We want to show that the connection of those two midpoints, RS, is parallel to this side HK. So here's what you could have. We want to use the midpoint formula to find the coordinates of the midpoints R and S. Then use the coordinates that you just found and the slope formula to find the slopes of RS and HK. Then we can compare those slopes and show that they are the same. Alright, we're going to do some more work during class. We'll have some examples. Please don't forget to copy those formulas down that were given during the warm-up for slope, midpoint, distance, and the Pythagorean theorem. Make sure you have those copied down. You will need those for the assignment. The back of your worksheet has graph paper for the problems you're going to need to use from the book.